FORTELION 24V battery module. Introduction example, AGV's AMRs. In recent years, the use of service robots and automated guided vehicles, AGV, at warehouses has expanded in order to improve productivity and overcome the challenges caused by labor shortages. The use of lead storage batteries for these devices has become popular. However, consumers had issues such as the long charging time and shorter battery life, as well as inconveniences when exchanging or carrying them due to the battery's weight. These consumer demands prompted the need to replace lead storage batteries with lithium-ion secondary batteries, which have a short charging time, longer battery life, and are more convenient when exchanging or performing maintenance work due to their light weight. Murata responded by developing the FORTELION 24V battery module that uses our unique FORTELION lithium-ion secondary battery, designed in the same size as lead storage batteries. And this module is being used at many companies. We'd like to introduce the reasons this battery is chosen along with an introduction example.
ASPINA is a manufacturer of precision devices, focusing on developing, manufacturing, and selling small motors. Until now, we've developed hardware technology mostly for motors, as well as software technology for controlling motors and other devices. Our new product, ASPINA AMR, combines both of these types of technologies. ASPINA AMR is an automated transport robot that helps to automate transport work at manufacturing sites and can make up for personnel shortages. It can be quickly put to use at existing manufacturing sites and can even handle frequent layout changes. It's also great at making tight turns in narrow paths. We kept on-site usage in mind when designing this product and made sure that it would be easy to use. We started designing the product assuming it would use a lead battery, which is a type of battery often used in electric forklifts. Lead batteries work fine in many fields, but their weight and low-weight energy density bottleneck performance. An increase in machine weight is directly connected with a decrease in payload, so we decided early on not to use these kinds of batteries. We decided instead to use lithium-ion secondary batteries. However, we had to spend a lot of man-hours on our design leading up to implementation, due to factors including charging-discharging, protecting the battery itself, and restrictions on usage environments. ASPINA AMR was designed as a robot that could work daily with human workers at manufacturing sites. We needed to satisfy several requirements for this. We needed to make sure it would be light and small, could operate for a long time on a single charge, wouldn't degrade much even if charged and discharged many times, and would be very safe to use. Another issue we faced at ASPINA was to reduce the number of man-hours required to develop this new product so that we could release the product at just the right time. We searched for a battery that could meet the requirements of our designers. There were three deciding factors. The first was that it fit our product concept for ASPINA AMR. ASPINA AMR was designed with a compact size and the ability to make tight turns so that it could easily be used in Japanese manufacturing sites, which tend to have narrow paths. In order to achieve this, we needed to reduce the size of the battery, which normally requires a larger occupied volume compared with other parts. Our product would be used daily at manufacturing sites, so it also needed to be highly durable and safe. In addition to being compact, the FORTELION 24V battery module offers some great features over competing products, such as no overheating in harsh temperature environments, and excellent storage and charging-discharging cycle performance. Our second deciding factor was how easy it was to implement it, helping to reduce development time. A standard lineup of FORTELION 24V battery modules with the BMU module integrated with the compact housing is available, so there was no need to spend man-hour on designing a protection circuit or control circuit. We checked with the manufacturer of our charger, and they replied that they had already verified compatibility with FORTELION 24V battery modules, so there weren't any constraints on what we could choose. This also helped to reduce the man-hours spent on development, which played a role in getting our product to market quickly. Our third deciding factor was an appropriate production quantity that would make it easier to investigate and then purchase products. Large-capacity lithium-ion secondary batteries, like the batteries used by ASPINA AMR, are not readily available on the market. Even if you can find a supplier, you typically have to place a custom order in lot units of several thousands of products. We continued investigating our options with the intent to use lithium-ion secondary batteries from the verification and testing stage, but our major issues here were the quantity and required initial investment. However, FORTELION 24V battery modules were standard products that could be purchased in small quantities, so the investigation and implementation phases went very smoothly. The smaller battery allowed us to develop a compact product capable of tight turns that could be easily used at manufacturing sites. We were also able to create a highly durable and safe product, and our customers have been very pleased with it. On these points, the FORTELION 24V battery module definitely plays a major role as a key device indispensable in realizing our product concept for ASPINA AMR.
Going forward, we will actively engage in efforts to solve customer issues using the FORTELION 24V battery module.